Hello. Today we're going to be talking about word problems. It is of my opinion that this is a tricky section. A lot of people struggle with this type of thing in Algebra 2. If you watch YouTube videos or something, they might do things a little bit differently, and that's okay as long as you're getting the same answers at the end. So we are going to talk about these word problems, and these word problems we're going to be using tables to solve. So let's start with a little warm-up. We're going to solve for x. Remember, you have a couple of options here. Most people don't like to leave 0 on one side, so I'm going to go ahead and subtract 6x here. That will give me negative 3x equals negative 2. Divide both sides by negative 3, and I get x equals positive 2/3. Okay, so that's a little warm-up on solving equations, and now we're going to talk a little bit about percents. Remember, the word of means multiply, and remember when we deal with percents that if you get 0.25, that would be 25%. So when it says what percent of 20 is 5, is means equal, it would be 20x, what percent of 20 is equals 5, and you would solve it, and you get 5 over 20, which if you type in your calculator will tell you 0.25, or you could change it to 1/4, but that's the percent, so x would be 25%. 25% of 20 would be 5. This time it says what is 40% of 20, so x is, what is 40% would be 0.4 times 20, and then x is 8. Okay, so these two guys here, if you want to pause and work ahead, that's fine. What percent of 630 is 189? Is means equal, so it'll be 630x, divide by 630. You'll type that into your calculator. 189 divided by 630, typing in right now. I get 0.3. That's not the percent. We got to change that to a percent by moving it 2 to the right. That is 30%. 16 is 20%, 0.2 of what number? Of x. On this one, you would just divide both sides by 0.2. You should get something bigger. 16 divided by 0.2 is 80. So x is 80. 20% of 80 is 16. Okay, so we're going to talk about these word problems today. And we'll use our same problem solving strategy, look for that question, figure out what they're asking. And today we're going to be using tables. So the problem solving process that we talked about, quick skim, find the question, state it in your own words, look for those clues, and our strategy today will be tables. So we're going to fill out the table as best as we can, and you will get better as you move along with these. Okay, so let's practice finding the question. How many gallons of pure water should be evaporated from 160 gallons of a solution containing 12% salt so that the remaining solution contains 20% salt? Okay, the question is asking me for how many gallons of pure water. That is the question. And this is what we call a mixture problem. This is the first type of problem we're going to be solving. And what you need to know about mixtures, it's a whole bunch of part over whole type of thing. Okay, so if it's 12% salt, it would be 12 out of 100. Okay, and 20% salt would be 20 out of 100. So what we're going to do is we're going to use this table that they're going to help us set up here, and we're going to figure out how much water we're going to have to take out to get from 12% to 20% because we need to have more salt in there. So here is our table. Basically what we're going to have here is your original, I'm going to cover this up a little bit. Your original solution, which was the 12%. Okay, so we had, how much did we have? We had 160 gallons of that. Okay, so we had 160 gallons of 12% solution. So how much salt did I have? Well, I had 12% of 160. So I would type that into my calculator. And that gives me 19.2, I guess, gallons of salt. That's a lot. Okay. We are going to take some stuff out. We are going to take out pure water, right? How much salt is in pure water? That's 0. So you have the 12%. We're going to take out the pure water, and we're going to get 20%. So how much salt is going to be in my new solution? That's going to be 192. 19.2, excuse me. Okay, so how much water are we taking out? That is what we do not know. We do not know how much water we're taking out. That is actually the question. How many gallons are going to take out? So that is the X. So how much will be in my new solution? Well, it's going to be 160 minus whatever we take out, which is what we're going to try to find out. So that is how you fill out the table here. And now we're going to try to solve it. So we are going to solve this to figure out the 20%. And the way we're going to do this is part over whole equals part over whole. So we're looking for 20 out of 100. That's 20%. And what I had here, and I'm going to have to go back, I had, what did I have? 19.2 over 160 minus X. So if I get this to be 20%, then I will know how many gallons I needed to take out. So we're going to go ahead and cross multiply. Okay, this will be 1920 if I move that decimal 2 to the right. And then I will have to distribute this. This will be 20 times 160 minus X. You can distribute it in your head if you think you can. This will be 1920 is 160 times 20. 3,200 minus 20x. Subtract 3,200 from both sides. So 1920 minus 3,200. Negative 1280 equals negative 20x. Divide by negative 20. My pen is a little shaky here. And I get x equals 64. And remember what that is. That's talking about 64 gallons of pure water that we're going to take out to get us to where we need to be, the 20% mixture. So that is a mixture problem. So what you're going to do is you're going to have what you originally have minus whatever you are taking out. Maybe sometimes we would have to add something to get our new mixture. And then we'll do part over whole equals part over whole. Okay, the next type of problem we're going to see is a distance, rate, time problem. And you will need to remember that distance equals rate times time to do this. I usually put rate time distance when I do these, but this is the same thing. Distance equals rate times time. So what are they asking us? Celeste rides her bike to work. She goes 12 miles per hour. On her way home, she averages 8 miles per hour. If the total trip takes 1 hour, how far does she live from work? So how far? That's a distance. We're going to be looking for a distance. And if you want to think of this, this is on her way to work. And this is on her way home. We don't know what the distance is, but isn't the distance the same? It should be the same. The distance in both situations is the same. I think I actually need to go to the next slide here. Yep, to work, return home. And what is the rate? The rate was 12 miles per hour on the way to work, 8 miles per hour on the way home. And this distance we don't know, and this distance we don't know. So how long does it take? Well, we really don't know that either, except we know that rate times time equals distance. So if the rate is 12, and I don't know what the time is, but my distance is x, the time will just be x over 12. This time would be x over 8. And the one thing I know is if I add those two times together in this column, I'm going to get 1 hour. So then my equation is going to be x over 12 plus x over 8, and that's going to equal 1 hour. So we're going to solve that equation. And there's a couple ways you can do that. You could, let me just try to give me some workspace here. You could use a calculator and use it as like 1/12 x plus 1/8 x equals 1 and combine like terms. Or you can say, you know what? I don't really like fractions, so I'm going to multiply by something to get rid of them all. And I would multiply by 24 because I can turn a 12 and an 8 into 24. 24 divided by 12 is 2. So this one would be 2x. 24 divided by 8 is 3. That would be 3x, and that's going to equal 24. So that would give me 5x equals 24. Divide by 5, and x equals 24 over 5. Remember, we're talking about distance, so that would be miles, but that's kind of a weird way to say miles. So I'm going to take 24 divided by 5, and that looks like 4.8 miles, which is usually how we express distances. Okay, so that's another table problem for you. And we already solved that equation. Time plus time equals 1 hour. Okay, now let's look at a work problem. A work problem is very similar. You're going to take the rate times the time to get the job finished. So if a student can type a 32-page term paper in 3 hours, the student's friend types it in 2 hours. If they work together, how long is it going to take the two of them to type the paper? So we're looking for a time. How long? Okay. So we're looking for a total time here. So this student writes a 32-page paper in 3 hours. So one paper can get done in 3 hours. Papers per hour. This one can do one paper in 2 hours. The time would be the same for both. And the fraction of the job complete would be a third of the job. Let's see what I got here. I'm giving myself more room here. 1/3, 1/2. Time we don't know. A third of the job and a half of the job. And all together, that gives us one job. So if I take 1/3 t plus a half of t, I'm going to get one whole job. Once again, I'm going to get rid of these fractions by multiplying through by 6. 6 divided by 3 is 2, so that's 2t plus 3t equals 6. Everything has to be multiplied. That's 5t equals 6. And if you divide out, you get t equals 6 over 5, which is about 1.2 hours. And that makes sense. It should take them less than this friend's rate of 2 hours to get done. If you wanted to take 0.2 times 60 to get 1 hour, 12 minutes, you can. I think they're going to be fine with the 1.2 hours. Okay, one last one to practice here on our own. A hose with a larger diameter working alone can fill a swimming pool in 9 hours. A smaller diameter, 18 hours. They're going to work together. How long for the two hoses to swim to fill the swimming pool? So we have the larger one and we have the smaller one. The rate would be one pool per 9 hours and one pool for 18 hours. We're looking for the time. And this would be a 1/9 of the job, and this would be an 1/18 times time, and all together, we're going to get one pool finished. So this would be 1/9 t plus 1 over 18 t. That equals one pool. Multiply through by 18. 18 divided by 9 is 2t. 18 divided by 18 is just 1t, and that is 18. 3t is 18. Divide by 3. And it will be 6 hours if they're both filling up the pool. So it should be quicker when they work together. Okay, you might have some questions on these word problems. Make sure you ask them. They're not easy for everyone. If we have to do more practice, we will.